Good morning. Let's stop talking about that. Let's start talking about like statistics. I'm gonna get back together again. Good. So, what do you remember about yesterday? Tuesday. What do you remember?
You're supposed to remember that?
Yes, kind of, ish. That is why I put the videos on YouTube as well, so you don't have to remember anything. You can just go back and revisit if you need to. What do you remember? Tell me anything you remember.
Standard deviation.
Tell me about it, Eric.
The average distance from the mean.
Okay. What else you guys remember? Tell me, what else? We have a sample standard deviation. We talked a lot about Bert and Ernie and sample standard deviations. Average distance from the data from the mean. Love it. Who else remembers anything else? Anything you want to tell me about it? What does it tell? I mean, it tells you average distance, but how can you use it to talk about data? Like, what is it? What was Ernie's? Do you remember what Ernie's was?
81.
That was his average.
Okay.
And then what was the standard deviation from the average?
1.58.
1.58? Good. So 1.58 average distance from 81. What was Bert's?
1.6.
Good. It was bigger, right? It was 16. It was like 10 times as big, if I remember. Somebody developed a measure last time, and it was 10 times as big, and this was also 10 times as big. Good. So what is the relative size of the standard deviation? What does it tell us about the data? Even if we didn't see the data here, but we knew, so low tech, sorry, but we knew that Bert's was 16 and Ernie's was 1.6. What would that tell us about the data? Tell me your name again.
John.
John, go.
Yeah, that on average, like the next set of data will end either below or above that many units from the mean.
Oh, good. Absolutely. How about Bert's 16 versus Ernie's 1.6? What does that tell us about as far as what the data looks like? Overall looks like on that number line? What could we...
Bert had a smaller, or which one's
16?
Ernie?
Bert's 16, Ernie's 1.6.
Okay, yeah, so Ernie had a smaller
Use any
set
word.
of consistency or whatever, and
Good.
then Bert had a larger set.
Yeah! We had Ernie super consistent, super tight, not much dispersion. Bert larger, therefore more dispersion, less consistency, more inconsistency. Good. So you guys remembered all the, I think, personally, all the important takeaways that I really wanted to get out. So these were, and you guys know, you paired it with the average right off the bat. Lloyd, you told me X bar was 81. That's what I needed to hear. You needed that. Eric, you gave me the definition. Perfect. It's the average distance between the sample average and the data. So you nailed that, and then John, you just wrapped this up for me. I mean, it's perfect. It's absolutely perfect. You guys, that's the big takeaway. I mean, we spent a lot of time doing that last class, but I think it's time well spent because we are now going to use technology to always crunch these numbers for us. But it's not the crunching that I want to test you guys on. It's how well you can take those numbers and actually do something with them. That's the point. That's the point of knowing what these values mean. I'm not testing. In Math 20 and Math 60, we were all about procedure. That was the point of those classes, or algebra classes, pre-algebra classes, algebra classes. You know, I remember sitting in 4th grade doing multiplication tables in front of the class, paralyzed with fear. But I mean, maybe it made me better, I don't know, maybe it made me traumatized, whatever. But that was skill building time, right? That was skill building time. You now have these skills. Let's put them to work. What can the numbers tell us? So yeah, good interpretations, very good interpretations. Love it. Anything else you want to share? This is what I pulled away. Anything else you guys remember or want to talk about concerns, questions, topics you want to get into about this? Or does that pretty much wrap it up? Or is it too early to ask that kind of question? Maybe it's too early in the morning to ask that kind of, yeah, let me get you guys warmed up a little bit first. Good. Okay, I want to now put this to work. So what I've got is I've got a data sheet that I've got a bunch of data sets on, and I figure rather than having you guys write them down, just grab one and hand it back to your neighbors. And I want to play with the data. I think we're done with Bert and Ernie. I think you get the point with Bert and Ernie. I think you understand it. Did we talk about, as you're handing that around, did we talk about the headlines from Mathematically Literate World last time? This is a website I stumbled upon. I use this as a segue. You guys probably calculated